Chapter 12, Lesson 4 is about adding and subtracting square roots, and this is where the fun really begins. When you add or subtract square roots, you can only combine like terms or like square roots. So for instance, if you had the square root of 5 plus the square root of 5 plus the square root of 5, it's like adding x plus x plus x, or apple plus apple plus apple. In other words, you just have 3 of what you're adding. Okay, so this would simply equal 3 times the square root of 5. It might help you to simply put a 1 in front of that radical so you know that you're adding those together and you end up with 3 of them. Okay, likewise, if you added up your x, the radicals of x here, you would end up with 4 square roots of x. Okay, we're able to simplify those expressions because the radicals are identical. Okay, if the radicals are not identical or your square roots are not alike, then you can't do anything with them. The square root of 6 plus the square root of 7 simply remain the square root of 6 plus the square root of 7. Likewise, the square root of x plus the square root of y is simply what it began with. You cannot simplify that further. However, by employing what you know about simple radical form, you often can simplify expressions of square roots. For example, if you had the square root of 8 plus the square root of 18, you can factor the square root of 8 into the square root of 4 times the square root of 2. You could also factor the square root of 18 into the square root of 9 times the square root of 2. I can take this. The square root of 4 is simply 2. Square root of 2 has to remain inside the house, as I say. Okay, square root of 9 is 3, and we end up with like radicals or like square roots. So now I have 2 of these square roots plus 3 of these square roots, which is a grand total of 5 square roots of 2. Okay, so by simply putting the square root of 8 and square root of 18 into simple radical form, I can then add them together because I now have like terms or like square roots. If I had the square root of 75 minus the square root of 3, well, square root of 3 is as simple as it's going to get, right? But you can probably tell that the square root of 75 is the same thing as the square root of 25 times the square root of 3, which would be 5 square roots of 3 minus that square root of 3, which gives me 5 minus 1 square root of 3, which is 4 square roots of 3. Got that? Okay. All right, and if I had this one, the square root of x plus the square root of 9x, well, I can take that square root right away, right? So I can have the square root of x plus 3 square roots of x. I have 1 square root of x plus 3 square roots of x, which is equal to 4 square roots of x. So sometimes it's just as simple as taking the square root that's already there. Other times you do have to factor. And you will, of course, get more difficult problems because that's what life is all about, right? Okay, so let's take this problem. If we had 75 plus the square root of 75 minus 27 plus the square root of 27, we would first rewrite it because we have that little subtraction sign which usually causes some trouble. Okay, so we know that in algebra we add the opposite. So that means this is going to become plus, but that becomes a negative, and that becomes a negative because those are their opposite signs. Okay, so I'm going to have minus 27 and minus the square root of 27. Well, I can combine 75 and 27, not in my head. I think it must be 48. Is that it? Let's see. 75 minus 27, just kidding, yeah, 8. All right, so we end up with 48, okay? But I have to deal with this and this. Okay, the square root of 75 we just did in our last problem, or one of our last problems. And we know that can be the square root of 25 times the square root of 3. And you can probably also see that the square root of 27 could be written as the square root of 9 times the square root of 3. So in other words, I can have 48 plus 5 square roots of 3 minus 3 square roots of 3 by taking the square roots of 25 and square root of 9. And now I have that 48 plus, and I have 5 square roots of 3 minus 3 square roots of 3, or 2 square roots of 3. And of course, this does not have a matching radical or a matching square root. And so that's as far as my simplification can go. All right, let's try a couple others. I just want you to be able to see the difference between these problems, because your book and your quizzes and tests are also going to throw these at you. If you have the square root of 4 plus the square root of 36, well, you can tell right away that that is 2 plus 6, which equals 8. However, the square root of 4 plus 36, you can't do the same thing with it. So you have to actually add it together, 4 plus 36, and you get the square root of 40. Now, because you do know that you can take simple radical form, you could say that it is the same thing as 4 times 10, right? So you can factor 40, which would give you the square root of 4, or 2 square roots of 10. Very significant difference between these two values, okay? So if both numbers are under the same radical sign, you have to combine them first before you do this process. If they're separated, they have their own little radicals, then you can simplify each radical first if possible and then add them together. And of course, if you have multiplication going on, you could, if you really like math, do 4 times 36 and find that really huge number and then figure out what the square root is. Or you can simply take the square root of 4, which is 2, and the square root of 36, which is 6, and then multiply those together to get 12, which seems to be a lot easier. So anyway, do notice the difference between these types of problems, because you will see those in your homework and on the quizzes and tests, and they're kind of intended to sort of trick you up to see if you can, figure out the difference. So there you have it. That's all you need to know. Go and have some fun.